The database is essentially a place as a server where you can store data. It's composed both of an application that will handle the data and also the physical, the storage, the folder and the storage where all the data will end up eventually. This is a way to keep the data that you want to store separate from the application on a separate space. So no matter what application wants to interact with the database, as long as they have credential and links to communicate with a database, you can do it from a laptop, from a mobile phone, from whatever. The database is there to serve the data. Whatever client wants to get the data needs just to communicate the data with the appropriate language and get it. So who makes databases? There are lots of companies that makes databases, but the biggest ones right now are, of course, Microsoft with MS SQL Server, which is the one that we happen to use with TMS, by the way. Then there's Oracle with Oracle 11, the latest version. There are some microsystems which is now defunct, has been acquired by Oracle, that develop MySQL. MySQL is an open source database that is very sophisticated now. Open source means that anybody can download it, install it, and use it. It's a free license. And it's used a lot, especially in association with a scripting language called PHP, to create dynamic websites. You will see a lot of websites on the web that use the technology between PHP and MySQL to create a dynamic website. And Postgres is another database, and IBM also, they have their own version. But I think the most popular are the first three ones, the MySQL, Oracle, and MySQL. So what is a database? A database is a repository of data. It's a place where you store a lot of data. If you try to store data in a traditional spreadsheet, like we have seen in some of the use, even here at Senecom, you run pretty soon in some limitation regarding the size of the file that you have to keep the data on. The fact that the data are stored in a single file, it gets very difficult to manage. It takes a long time to open. It's difficult to search the data. With a database, you have a different concept. You essentially store information in different tables organized by the type of data that you want. And then the database creates relationships between the tables so that when you pull information from a table to another based on that relationship, is very fast. So what is a table? A table is a collection of data entries that are related. For example, you can have a table for customers where you keep the name of the customer, the address, the phone number, the ID of the customer within the company. Or you can have, for example, in the case of TMS, just to make a specific example, you can have the test cases where you have the title of test cases, the steps, the type of score that you want, if it's a pass or fail or a score. So if you look at the picture on the right, that is the snapshot of the tables that are actually contained in TMS. I will make a lot of examples with TMS because you guys are more familiar with it. It's probably better to refer to something that we do every day. So if you see on the right, that's a list or partial list of all the tables that are appearing in the TMS database. Yes, Miguel, go ahead.
Maybe so the database is separate from the web GUI we use to input that data.
That is correct.
So these snapshots, how the tables get created, do you need to prior have a web GUI already made in order for this to get created? Or
to create the table?
Web GUI
no. In order to create these tables, you had to have installed the database program, MS SQL or Oracle for the matter, on a server, on a specific server. That is a job for a database administrator, which will create the schema for the database. It will ask you, what kind of data you want to store here. How do you want to organize them? So you say, well, we have devices, we have test cases, we have test lists. So he will pretty much design the schema of the database and then start creating the tables, indicating for each table what kind of data you want there. You want numbers, you want strings, you want long strings, you want a number with floating point, whatever. I mean, you want images. So that's the job for the database administrator. He will create this. And then somehow it's job of the developer to create a web application that asks the question or query in technical term to the database. So the web application, where you click a button after you ask an information, for example, look for all the test cases that contain the word electric, the web application will send the request to the server. It will query the database and will return and format the information that you want. So again, this is an example of how the tables are organized in TMS. And just to make an example, the first one, for example, AppDev, is the table that contains all the information that the carrier enters when he enters all the devices. So it has the model, the name, if it's a pre-release or not, the version of the software, when it was loaded, who's the manufacturer. And then there are other tables. For example, here you have program. Oops, I'm sorry. Go ahead. Program is what programs are the devices associated to. So you have a phone is associated to AT&T, or maybe it's associated to Verizon. Now the idea is to keep the devices on a table and the program on a separate table. You don't want everything together. And then when you need, you have to associate the two information together. That's what will be done by the web application.
If you want to know what device on what program it has to
Exactly. Exactly. So instead of having a humongous table with all this information that is unmanageable, you just keep the information separated. So you have a table for the customers, a table for the program, a table for the test cases, a table for the devices, and then they're linked together. We'll see in a minute how they do. So this is an example of a table. See, this is a table of the test cases for TMS, where you have the test results type. For example, H stands for score, a score from 1 to 5. If it was 7, it would be a pass or fail. And now guess what? There is a table that has two columns. One says 7, and it says pass, fail, and one says 8, and it will say this is a score. So you don't have to indicate here if it's a score. It just refers to another table that had that information. That's a good example. Here you have the name of the test case, the test ID that identified uniquely, and then a bunch of other information. When you see null, it means that there's no data in there. Okay? But this is pretty much like a table look like. It's similar to a spreadsheet, but we will see in a minute that the database does much more than just creating tables. It will create some rules in how to handle the tables. So the tables are organized, again, similar to a spreadsheet, in fields and records and columns. Okay, every table is broken up in fields, which are essentially the header of each column. Will tell you what the column contains. The column is all the content of vertically associated to that field, and a record in database term is pretty much a single line inside the database that describes a single element of the table. For example, this is again the table that we saw a minute ago. As you can see, there is a field called a name. There's another field called a test result type ID, another field called a test ID. The column of the test ID contains all the test ID for each and every test case. And a row identifies a single instance of an element inside a table. For example, this test case here, the row has the ID 4, test result type ID 8, etc., etc. So pretty similar to a spreadsheet. On a database, there are some special columns that are called the keys, and here's one of the step forward in the database, that are very important because they identify a particular record in the table. Think about it. When you have a device, for example, you can have manufacturer, name, model, whatever you want, but to uniquely identify a device, you better give them an ID that differentiates from any other device. Because, for example, on a table you can have 5 different iPhone 4, but how do you differentiate one from the other? So one of the things that the car does when you enter the device, it puts a barcode. And the barcode identifies a device, no matter if it's a cable, a headset, or a phone, uniquely. So that's in database terms called a key. It has to be unique. If you have a database of people, even within the company, for example, Satacom, you can even have people with the same name, with the same last name, but they all have a different, for example, social security. Now that's a key because identify uniquely each line, each record for that specific person, so there is no misunderstanding. So when you create relationship with tables, you essentially link them through the keys that they own. For example, there are two fundamental keys in a database. One is the primary key that identify uniquely, and I'll show an example in a second, uniquely identify the characteristics of each row, and then a foreign key on a separate table that identify the matches from the primary key. Okay? Let me give you an example. Look at these two tables. We have a table where you have a list of IDs for artists and their name. For example, the first one is Bono, the second one is Cher, the second, So you have a field here that is called artist ID 1, 2, and 3. You can have a separate table later with the albums that these people make, where you have the artist ID, for example, here is 3, which is coming from here. That means that this guy is this album belongs to this guy. You can have another album. Forgive me if I make a mistake in the album, it's just an example. But for example, Crave is another album associated with this ID, which is still Nuno Betancourt. Here you have another album which is associated to. So you can see here that you have multiple numbers here for the artist ID. But they all come from a separate table, which is this one, that has the primary key identified uniquely. So the fact that you can have multiple keys here, identify this as a foreign key because it derived from another table. Here you have a primary key that will be unique, but okay, when you create an artist, well, when you create an album and you want to associate the artist, you have to borrow it from here, create a relationship from here. So how do you know who is the artist associated to this album? You have to find which is the artist key. You have to create a relationship that allows you to go back and say, it's number 3, it's this guy here. So this information is stored in this table. Here it will be just used, okay? That's the foreign key.
So if it gets updated with a primary key.
Right. If you add a new ID here, for example, number 5, and you put Bruce Springsteen, now you can, on the other table, you can start creating albums associated to Bruce Springsteen. Okay? Exactly, it's number 5. So you don't have to put here the name Bruce Springsteen. You just put number 3 because you have a table that holds the information Bruce Springsteen. Okay? So that's one of the way the tables are related in a database. You don't have to put the artist name or the album name and all these things in a single table. You just create 2 separate places, and then you just link together. You know, say where we use the artist ID 2, which is coming from that table, and so you can find it. There is a fundamental concept in database that is not used on the spreadsheet. In a spreadsheet, you can do whatever you want. You can copy records here and there. You can copy IDs and names. But look what happened if you, back on this one, if you start adding here on this table an artist that doesn't exist on the other table. You start adding Bruce Springsteen on this table, and it says number 5. And the table says, who's number 5? There's no number 5. So the database will complain, will not allow you to do that. He will essentially tell you, first you have to create the artist on one table, and then you have to create the album on the other table because you have an artist. This kind of, the database is trying to preserve the fact that you cannot create a data using data that don't exist. Okay? This is called referential integrity. The database is essentially saying before you even create an album, you have to create the artist because you have to link them together. The other consequence of that is that if you have, let's say, an album here that says Bruce Springsteen number 5, or even this one, the 3 and 3, and you remove this one, all of a sudden, here on the album list, you have a bunch of orphan records that don't have an artist anymore. Once again, the database will not allow you to do that because, again, of the concept of referential integrity. When one table is a foreign key to another table, the concept of referential integrity states that you may not add a record that contains a foreign key unless there is a corresponding record in the linked table. This is a powerful thing that the database do that the spreadsheets don't do. And that's why you are allowed to create separate tables because you're comfortable with the fact that the database will check all the references. So these are the 2 fundamental concepts for a database. Let's get to SQL. What is SQL? How do you get all this information from a database? You got to talk to a database. Okay. Now they come up with the programming language SQL that is pretty much English-like. If you read a SQL statement, you'll be surprised how similar it is to the simple English language. However, it has its own syntax, has certain commands. You got to be precise when you use it. But when you read a SQL statement, it will be pretty simple to understand. So SQL allows a script or if you have a prompt box, you can run commands directly to the database to, depending on your level of credential that you have on the database, you can simply query for information, so read what is in the database. If you have a higher level of credential, you can modify data into a database. If you have an admin level on a database, you can even create tables or create schema into a database. Okay. SQL uses some simple keywords like create. You want to create a database, or you want to drop a database. It means delete a database. Select. Selecting SQL means pretty much show me. You know, select certain elements. It means show me how they look like from the database. Show me a table that shows them. Insert. You can insert a new. You want to add Bruce Springsteen to the table. You have to insert whatever SQL will allow you to insert. Where, for example, is another. It's a conditional where you say, for example, show me all the artists where nationality is Spain. It will only show you the artists that are from Spain according to a table. Like, for example, is another. Show me all the record that start with the word Bruce. So you say like Bruce, and so we'll put Bruce Springsteen or whatever other artist. So the keywords are pretty simple. Now let's see an example of a query. So these are two simple queries that I created just to see what's inside the table. So the first one says select, which in SQL language means show me. The star here is like is a wildcard character. It means show me everything. Instead of asking the specific, show me everything. Yeah. From customers. Customer is the name of the table. So SQL is essentially saying go to the customer table and show me everything that is there where the last name is equal to Smith. This is pretty straightforward. Go to the table and show me everybody with the name Smith on the column last name. Or here, for example, this is something that HR might do. Select everybody from customers table, order by, show me all the customers, and order them by name. And then after you order by name, order also by salary. So the people that start with an A, and they show the richest people on the top, the middle people on the middle, and then B, the richest people on the, and so forth and so on. So SQL is very powerful in retrieving information from a database. Operators are used to give some more information about what you want from your query. For example, show me all the names that are equal to Bruce, or show me all the salaries that are not equal. Or show me the salaries that are less than $1 million. You want to see all the people that have less than $1 million salary. Or show me all the ID for devices that are bigger than 35, and it will show you only those. Or you can use a range between, or that have a specific pattern. For example, show me all the devices that contain the word Apple. So like Apple, and so forth. So I made a 2 or 3 example of a query, and we'll make it a little bit more complicated on each slide. So this one, for example, says, and this is a real TMS example, show me the type ID, the manufacturer ID, the name of the model, from this table. Well, this is a little longer because it said this table that has been created by the owner of the database, the guy that is logged into the database, and that is inside the database called TMS. So you have an exact idea where the table is inside the database. Okay. That will make it a little harder to say, okay, show me all the information that I said to you, you know, type ID, manufacturer, name, and model from that database where the type ID is 56. Now, there's a table on TMS that says every device has a type ID. For example, 1 is it's a USB cable. 2 is it's a Bluetooth microphone. 3 is a stereo Bluetooth headset. 4 is, I don't know, a tablet. 56 is a handset. So it's a cell phone. So this query is simply saying, show me all the cell phones that are on the database, on the device database. Don't show me the Bluetooth ones, don't show me the USB cables, the memory stick, only 56, which is the handsets. Even more complicated, okay, show me all the handset, show me the type ID, the manufacturer, and order them by name. So you will see Apple first, and then I don't know, Bose second, or whatever. The result of this query is this. You see, select type ID, manufacturer ID, name and model. There it is. From app dev, which is the table that contains the devices, where type ID is 56, see all 56, doesn't show anything else, and order by name, Amazon first, then Apple, then Asus, and then HTC.
So the actual, in the from line, the table will always be last. If it's,
Yeah.
regardless of
First,
subfolders or wherever it's in,
yeah.
the last thing is all the name of the table.
First you indicate what fields you want to see.
Right.
Then you say from what table.
Right.
And then whatever conditional you want. Okay. What do you do when you have to pull out the information from two different tables? For example, the artist is in one table and the album is in another table, but you want to aggregate the results on a single table so you see the artist name and the album name. Okay. That operation in SQL is called joining. When you do a join between two tables, first you have to decide how do we join the two tables. I mean, where's the common ground between the two tables? Well, we spoke about the keys earlier. If you have two tables that have the same key, for example, the artist ID, now you can join them because the database will know for each ID on one key, where's the other ID on the other key. For example, here, these two tables share a common key, which is the artist ID, and the artist ID here. So these two tables can be joined because they have a common column. So what do? These are fairly more complicated, but not too bad. Instead of putting one by the other one, I put here the fields that we want to see. So the SQL query said, select, show me, from the table appdev, the ID, from the company table, which is the other table, the company name. Then again, from the appdev, the name. And they're sequenced so that you can see them in the same order in the result. And then you show me the production code for the device ID, and device ID show me also if it's a pre-release or not. Now, where do you get to this information from? You get it from the table appdev, which is inner joined with the other table, which is called company, where this field on this table is equal to the same field on the other table, because the ID table, the ID column and the ID column on these two tables contain the same data. So you're telling the database how to link them together. What is the relationship between the two? And then, of course, since we're here, just order them by manufacturer ID. This is what you get. Well, actually, these are the two tables, actually. See, the appdev, there's ID here, and the company has another ID column here. These are the same number. They're same key. But then the information here are different. This is the manufacturer ID, type ID, and here you have the other information. You have the company name. So you're linking the two tables together with a single query. And what you get is this, which contains a column from the one and a column from the other. But now they're together, so you don't have to jump from one to another. You have an aggregate example of these response of all the results. So you have the company name here all of a sudden, and you have the product on the side, okay? And the ID is the original key from the table. This is going to help you understand how, what is that? Network connection difficulty. Okay, I don't care about that. This is pretty much how, from a web perspective, the whole process works. You're sitting in front of TMS or eBay or Amazon, and you're searching for things that are in the database. How does it work? The whole flow is this. You enter some information into your web browser. Okay? Your HTML code in the page that you're about to send to the database contains some things that you want to know. Well, there will be a script inside the page that will take care of collecting this information. For example, you're saying, show me all the album for Bruce Springsteen. The script will collect the name Bruce Springsteen. We'll pass it into an application server, which is a program that will filter those requests of data. For example, show me all the Bruce Springsteen. The script will say, okay, you want Bruce Springsteen. Let me talk to the database. It will send the information to the database. The database will pull out all the album from Springsteen, return it to the application server. The application server assembles the web page and send it back to the browser. And you will receive a page that doesn't contain code. It just contains the list that you want. So the application server essentially is the guy that speaks the language for the database for the web browser. Okay, it's a kind of a translator. It will say, what do you want to know? Well, I want to see, serve me a table with all the Bruce Springsteen album. The application will talk to the database, pull out all the information, will format them depending on how you want them, and then send it back.
So essentially, on the bottom line, step 2, HTML language is making a call, I guess is the right phrase. It's calling out for information. The application server interprets it, shoots it over to the database, which gets it back, brings it back, and answers the call on step 8.
Right.
And says, okay, now I have the information I was waiting for.
All right. As you know, HTML is a static language, meaning you write it and we'll show you whatever you want to write. But the problem is, well, what if I want to see something dynamically? I want to ask it information and want HTML to render it. You have to use, in that case, some scripting languages, such as PHP or JSP or Cold Fusion or whatever. Embed that script inside a web page. When you hit that portion of the code in HTML, it will see the script and say, okay, what do you want? What information do you want? The script will say, what artist do you want? You say Bruce Springsteen. The script will talk to the database, get the information, put it back where it was initially, replace essentially what you asked for with the answer, and HTML will render. Here's an example. This is a PHP, and I don't want to get too technical, but this is a PHP script that you can embed inside an HTML page. So when you get here, the PHP will select, will run a query. See the SQL query that we wanted? And then once it gets the result from the database, we'll give it back to this part of the script that will say echo, which is show it on the screen, where you show the first name first, and then you show the last name. And as long as there's first name and last name, it will continue to write them. So all of a sudden, we'll create this table, HTML grabs it and put it on the screen. That's all it does. It said, okay, you wanted me to find this information. You want them formatted like this. I'll grab them and I'll put it back on the screen. Okay? This is even more complicated because here, for example, they have a query. Select this from friends where pet equal to cat. And then he's formatting a table where he wants to see the name, the color, the food, and the pet formatted in the table. Hey, Nimesh. Again, this is getting a little technical because you need to go into PHP and start using scripting language, but that's pretty much what it does. The application server will wait for you to input information, Bruce Springsteen, or show me all the coffee mugs. The PHP will talk to the database through the query that is embedded in the script, get the result, and replace what you asked with the results, and it will be formatted on your screen, and will come back on your screen. Okay. That's pretty much what I wanted to talk about. And then, there's the last page where you can find more information about SQL, etc. So once again, the databases are just a place where you can store data and organize data and link tables that contain the data together. SQL is a language that is used either by somebody that have a SQL query application just to query it. Like I have a SQL, what is it called, management series, Microsoft SQL management. Yeah, where you can see the table, or the SQL strings, the SQL query can be embedded into a scripting language just to collect information and render them on a browser, which is what you do when you have a dynamic website. Okay? Any questions?
No, that's good, actually. I'm doing well.
The data can be any type of data, doesn't necessarily need to be strings.
The data that you have in the database,
yeah.
The data that you have in the database, you decide what you want. It can be strings, it can be values, it can be pictures. Actually, for picture, I think the database stores the location, but then the picture itself is stored in a folder.
One is location, and also you can store the image on the SQL Server database.
Yeah, yeah.
So you can reference
it is stored in a bit. It will be stored in the bytes. So the picture will be compressed into. If you take out the entire bit structure of the image and store it into the database.
Yeah, you can store pretty much you want. The only thing is that when you design a database table, you got in advance you got to start thinking, okay, what do I want to store? Because I have to define what type of data I want. For example, if you have the pre-release code, for example, for a device, what kind of field is that? That's a checkbox that is either checked or not. So you have to put a constraint on the cell, for that column that says is either 1 or 0. If it's 1, means that it's checked. If 0 is not checked. Okay? So that's the only conditional you want. But if you want, for example, the model of the device, you have to say this field will be a string with a maximum length of 256 characters or whatever, which is the constraint that you will have when you type the name. If you have a device ID, you say, okay, this is going to be a numeric value, an integer of maximum, I don't know, 16 digits. So you have to decide in advance what do you want, because then the database will accept only value. If you try to put the letters inside a number, the database will say, no, they told me initially that you want a number here, not a letter, so you cannot put that. So it will give you an error message. If you put a string that is longer than 256, at a certain point you will see that you cannot even type it because it will not accept any more characters, because originally the database architect who designed it said this is a string maximum 256. So all these rules that are enforced by the database, it's what makes the big difference between a spreadsheet, where you can do whatever you want, and a database. The database have all these constraints. Okay.
And you can only have the primary and the secondary for the table ID, or can you have more than one?
Well, you have to have a primary key that identify uniquely each line of the table. On the other one, on a related table, you have a column that uses the primary key from the other table. Okay, the foreign key, exactly. And it might also have his own primary key. Actually, every table has to have a primary key. Every table must have at least a primary key. You can have more than one, yeah, because on the other one, essentially, yeah, essentially the foreign key on the second table is using multiple instances of the primary key from the other table. On the other table is unique. For example, the artist ID number is unique, but on the album list, you can use it. Yeah, yeah. I mean, the Beatles have 30 different albums, so you have 30 different lines, which the ID would be 30 times, but the ID originally is from another table. On that one is unique, but on the album list, you can use it more than once. Okay, so that's the idea. These are this is why the database is so powerful, because they employ a number of rules on the background that allows you not to confuse, not to mix, not to create illogical, relationship between the data. Okay. That's pretty much it. So the link I put here is the W School is a very good website. You can learn pretty much anything from HTML to CSS to databases, SQL, anything you want. It's very good. I would recommend you go there if you want to find information, and you will find a little bit of everything.